Good afternoon. Today I am going to give presentation on Khosla's theory. When hydraulic structures are founded on pervious foundations, there may be problems of piping and uplift. Piping is prevented by providing sufficient length of floor. And uplift is prevented by providing sufficient thickness of floor. So now Bliss and Khosla given solutions for these problems. They given formulas. According to Bliss, suppose this is structure, these are cutoffs, upstream cutoff and other one is downstream cutoff, and this is wall. So here there is water. So Blay assumed that the creep of water along bottom line of structure. So like this. So upstream to downstream. So this is the creep of water at beneath of the structure. And he given formulas for prevent piping. Sufficient length of floor L equal to C into uplift. So here C is Bliss coefficient. He given for different soil values for his coefficient, and thickness of floor he given formula uplift by specific gravity of material minus 1. So suppose apron is submerged, so this is the formula. If there is no water, that means it is not submerged, apron is not submerged, so this minus 1 is not come. So according to Blay, he given formulas for solutions of piping and uplift. Now Khosla. So same structure, upstream cutoff, downstream cutoff, and here there is water. So according to Khosla, the seep of water is as like streamline in the flow net. So this is the first assumption. And the second assumption of Khosla is piping from downstream side, that is called undermining. Undermining is from downstream side. Due to scour problem, there is possibility of undermining. So that hollow is formed and our structure is collapsed. And the third assumption, so he introduced gradient, exit gradient. So exit gradient between water pressure and submerged weight of soil grain. So near downstream side, if submerged weight of soil grain equal to water pressure, that is critical condition. That gradient is known as critical gradient. So our safe exit gradient should be within 1/4 of critical gradient. So critical gradient for reverse ends equal to 1. So 1/4 is the safe exit gradient, that is 0.2 or 0.25. And fourth assumptions of Khosla is uplift pressure not only from subsurface flow but also from surface flow. So whenever there is hydraulic jump is formed, so there at the starting of hydraulic jump, the ordinate of uplift pressure value is more. So then uplift equal to subsurface flow and also plus that surface flow. So this situation generally occurs in canal falls. So uplift pressure also surface flow. So this is the fourth assumptions of Khosla theory. So now Khosla given a method, simple method. So this is rather than a complex method as like electric analogy method, flow nets. So Khosla introduced independent variables method. So in this, a complex profile is divided into 3 simple profiles. So Khosla divided a complex profile into 3 simple profiles, such as first one is a horizontal floor with negligible thickness, with negligible thickness with upstream or downstream cutoff, with upstream or downstream cutoff. And second simple profile is a horizontal floor depressed below the floor, depressed below the floor of structure without any cutoffs, without any cutoffs. And third simple profile is same, a horizontal floor with negligible thickness, horizontal floor with negligible thickness consists with intermediate cutoff. So first one is upstream or downstream, and this is intermediate cutoff, and the second profile is without cutoffs. So Khosla given formulas for each profile, and these formulas are valid only after corrected. So there are 3 corrections are there. Corrections of corrections. Mutual interference of piles, mutual interference of cutoffs or piles. Cutoffs or piles. And the second one is length of floor. And third correction is slope of floor. So for these three corrections, he was given formulas. So after corrections of those already we discussed, simple profile formulas are valid. And also Khosla given formula for exit gradient.